Hello everyone, I'm Mohammed, and in this video I want to showcase how I use Azure Data Explorer as a data source for Grafana to analyze my Whoop fitness data. I took this as a challenge to myself to see what Azure services I can use to build a complete pipeline from Whoop APIs to Azure Data Explorer and Grafana. I really wanted to use Azure Data Explorer, which is a data analytics service that provides a really powerful query language. I'm a big fan of Azure Data Explorer, and I use it professionally as a software engineer for application monitoring such as logs and metrics. But I really wanted to use it as a playground for my own personal data. So I figured tracking my Whoop fitness data is a perfect use case here, since the data is somewhat like time series data, and there is an opportunity here to do some awesome analysis. Let me show you first the dashboard I built in Grafana and then show you my full approach on how I pull the data. So let's now go to Grafana. I'm using Grafana Cloud with free account. So here is the dashboard I built. I reproduced some panels based on Whoop mobile app dashboard, but also added my own panels. Here I'm going to use the last week of August for my time window, just because it has better data. My favorite two panels are these two. The first one is a status history panel that tells me which days I've been active or lazy. I use a strain metric with a threshold value to determine whether I met my physical activity goals or not for that particular week. My second favorite panel is this table panel to list all my workout during that week. Another nice little feature I added is the ability to drill down on a particular workout. For example, let's drill down to the workout with the highest calories burned over that week. For example, this one right here. This takes me to another dashboard with more detail about that particular workout. And all these panels are just queries from Azure Data Explorer, as you can see here. Let me now show you how I pull my data into Azure Data Explorer. So my approach is just to have a data pipeline that runs daily to ingest my Whoop data into Azure Data Explorer and then connect it to Grafana to build my dashboard. So here is a high-level design of my approach. As you can see, I use Azure durable functions. This is where I have my workflow for fetching Whoop data via REST API for storage. Second, here we have Cosmos DB, which is my storage solution to store my Whoop data. There are two reasons why I chose Cosmos DB. First, since it's a NoSQL database with support for unstructured data, it is perfect here since we're dealing with JSON data. And second, it has first-class support to connect with Azure Data Explorer. So Azure Data Explorer requires a data connection from a data source. So in this case, we established a connection with Cosmos DB to listen to any changes in Cosmos database and ingest those changes for processing. So let's first start with Whoop APIs. So they actually provide a super awesome documentation for their APIs, and I highly recommend that you check them out. I just wanted to highlight the type of data or resources that we'll be fetching. So as you can see, we have four types of resources: cycle, sleep, recovery, and workout. Each of these resources provide metrics that tells you about your health and fitness. For example, in a cycle, you have metrics such as the total calories burned and maximum and average heart rate. Sleep has other metrics such as sleep consistency and efficiency. So these type of data will be fetching and storing into Cosmos DB via Azure Functions. So let's now switch to Azure Functions. I'm now on Azure Portal inside my Azure Functions resource. As I mentioned earlier, I'm using Azure Durable Functions to orchestrate my data workflow from Whoop to Cosmos DB. Azure Durable Functions is just an extension of Azure Functions where you can run stateful functions to build a workflow. As you can see here, these are all my functions that I have to build my workflow. Let me show you a diagram to explain what each of these functions are doing. So here is my workflow with all my functions. We have three types of functions here. So the first one is we have a classic or regular function called my test function. I know the name is unfortunate, but I just never got the chance to change it. The only thing this function does is invoke the workflow based on a trigger. Here I use a timer trigger where this function is invoked based on a cron job so that it runs on a scheduled basis, which I set to run daily. The second type of function is orchestrator functions. I have one here called whoop orchestrator function. This is where I build my workflow to trigger other activity functions. The third type is activity functions, which are just stateless functions that are invoked by the workflow orchestrator, as you can see here. This is where I do the data fetching and loading into Cosmos DB. So starting first with the refresh token activity, this function just grabs an OAuth token so we can talk to Whoop API, and then we invoke all these other functions that just fetches Whoop data and put them into Cosmos DB. So I wrote all those functions in C#. If you look at my solution, I have 4 projects. The core project is where I have all my logic, and I have a console project just for local testing, and I have an SDK project which is just a client library to call Whoop API. This project is almost 90% generated from OpenAPI generator. And then I have my functions project. This is where I have my workflow. So I have a single class here besides the startup class called Whoop Orchestrator, which basically does what I described in the diagram. As you can see, the first step is I call the refresh token activity function, and then the rest of the calls are just for calling functions to fetch the data and dump them into Cosmos DB. So let's now switch to Cosmos DB to show you how my data looks like. I have one container for all my data. I have 2 types of JSON documents in my container, each one differentiated by a type property. For example, I have items with type cycle. These contain denormalized data containing metrics from cycle, sleep, and recovery combined all together. I did it just to keep things simple. And I also have items with type workout. For this particular type of items is just a direct dump from the API response. Let's now move to Azure Data Explorer, also called ADX, which is the analytics service I'm using to analyze my data. Full disclosure, ADX is more meant for big data analytics with high volumes of data. So cost-wise, it's probably an overkill for my use case, but I really wanted to benefit from its powerful query language, and I think it's worth it. If you look at their documentation, they tell you when to use ADX, and in my case, interactive analysis powered by ADX query language is my main reason for using ADX, which made it really easy to build my dashboard in Grafana. So back to Azure Portal, I have my ADX cluster with a single database. In my database, I have a data source connection for Cosmos DB such that it ingests any data changes in Cosmos DB. In ADX, you also need to define the database schema and the mapping between your schema and data source, which in my case is Cosmos DB. You can find all my scripts for schema definition and mappings in my GitHub repo, which is shared in the description. So now we're ready to query data in Azure Data Explorer. So now we can use Kusto query language, or KQL for shorthand, to query our data in Data Explorer. So we have 2 tables here, cycle. Let's take a sample of 100 records. So this is the data that was ingested from Cosmos DB, and then let's look at workouts. So let me show you some very basic queries. I won't dig too deep into them. The query language is really powerful. There are a lot of training material on them, but let me just show you a very basic one. For example, I want to see workouts where the time is between 2 weeks ago, 14 days, and now. So now we have a filter of all the workouts I did. Now let's look at only the columns I'm interested in. Start, sport, kilojoule, how much calories I burned. Now I don't like this kilojoule unit, so let me just convert it to a calories or kilocalories. So now we can do something like this. Extend calories equal kilojoule divided by calories conversion. Let's now do some aggregation. So I want to find out the workout where I burned the most calories. I can just do summarize argmax by kilocalories or so calories. Then I'm going to grab all columns. Actually, I just want start, sport, or what activity it is, and yeah, that's it. So the final piece is adding Azure Data Explorer as a data source in Grafana. Luckily, Grafana has a first-party connector for Azure Data Explorer, as you can see here. So I just followed instructions to set it up. So basically it tells you to create a service principal and assign it a reader role with a viewer permission to your ADX cluster. So now that I have my connector configured, we can now run queries directly from Grafana. And finally, from this point on, I was ready to build my dashboard.